So thing is, why not at the center? And then most of people actually, right, would reject this idea that the galactocentricity, and then basically we become like conspiracy theorists. We have to be very careful, right, when you say this kind of thing. The question is, are we really sure that we are at the center? Not so fast. It's not that simple. The Humphreys interpretation of the galactocentric universe based on Tips and Napier and Guthrie's observation is stunning and interesting, but I myself personally wouldn't put too much assurance of it because the claim was made based on very limited data. We have our galaxy alone has 200 million stars, and then you have another 2 trillion galaxies in the universe, and these people just measured hundreds of galaxies. One can also still explain the observation based on the Big Bang framework, even if the observation of this periodicity shows that we are at the center. There's still another explanation from the Big Bang framework. So it's not that simple, okay? But then more interesting recent research emerged. So astronomers from Sloan Digital Sky Survey have made the most precise measurement to date of the cosmic cluster of galaxies. The SDSS utilizes a very sensitive digital camera that can take pictures of the night sky in various colors to determine the position and brightness of millions of celestial objects in 1/4 of the entire sky. They made the best three-dimensional map of the universe to date, mapping over 200,000 galaxies up to 7 billion light years away, over 6% of the sky. The SDSS team has published a 2D slice of the galaxy map on their website. The map looks like 2 slices of pizza, right? Because the Milky Way galaxy obscures the view for much of the mid-sky. You go to this SDSS webpage and you can find several color images like this or like this. Okay. This is not from that webpage, but also this is another stunning image here. Now here, the small dots, each representing a galaxy. Can you believe that? The small dots, each representing a galaxy, appear to form into enormous concentric structures here, centered in the middle where our galaxy is located in this map. The galaxy density seems to decrease and increase periodically with the distance, which is kind of opposite from this Big Bang estimation. But anyway, a creationist scientist, John Hartnett, used the 2005 Sloan Digital Sky Survey data to analyze the locations of 400,000 galaxies, showing the periodicity of measured galaxy redshift. The usual interpretation is that this is evidence of the cosmic web. You see this so you see this graph. This shows that statistically, these galaxy distribution really are sort of periodic, okay, not sort of homogeneous. But this can still be interpreted using this Big Bang framework, saying that this is evidence of the cosmic web and including voids and long filaments of galaxies, which can be explained again within the Big Bang framework. So you can explain anything because you cannot really prove it. You can explain, no proof. Anyway, but an alternative interpretation would also be possible, such that galaxies are preferentially found at a certain distance or certain redshifts, which implies that these are real space structures. In summary, there are 2 possible interpretations of the data. One is the redshift periodicity is evidence for past oscillations in the expansion rate of the universe. There is a Big Bang framework based on this, rapid inflation, cosmic inflation theory, and so on and so forth. However, there is another explanation that our galaxy is somewhere near the spherical center of a very large super structure of galaxy. Actually, he has another thing that I decided not to put it in this lecture, that he has another conference presentation now, because this is journal. This is a secular, mainstream journal, so you cannot really say, oh, center galactocentricity. There's no way that your paper is accepted, right? So he has put his conclusion very carefully. You can explain this within this Big Bang framework. Also, there is another possible explanation. He didn't even mention this in this paper. But then there's another conference that after 1 year after, so this is 2008. So 2009, there was another conference. There's the second crisis of Big Bang cosmology, something like that. So conference, you can do it a little aggressively. There, he presented, actually, we are not exactly at the center of the universe, but we are near the center of the universe, like 1 billion light years away. 1 billion is a huge number, but considering the entire universe, 920 billion light years in diameter, 1 billion is small, right? So if you're not at the center, but if you're near the center, then there's only one interpretation. These structures are real structures. Okay, so, but the rendering was not clear. The data was not 100% assured because of this noise and so that's why I decided not to include it here, but there are other research results. So here, my question here, why does it matter? Or why does it not matter? Whether or not we are at the center of the universe. Why does it matter?
This is just a guess.
Okay.
Does it show some sort of intentionality with God creating our galaxy?
Okay, yeah, that's a good thought, and that is sort of close, sort of approaching the answer here. Anyone else? One more?
If we are created by God, who is infinite and eternal, could it be that God has a large-scale plan for the entire universe that would include us? And if we are the center, then maybe on an eternal scale, we could be thinking of humanity expanding God's reign over the entire universe. I don't know. Maybe that's a way to think about.
Yeah. That I think that's a good thought. Interpretation that we may be at the center or near the center of the universe contradicts the cosmological principle. So here, the cosmological principle is the key. It contradicts the cosmological principle, which assumes the uniformity of space on the sufficiently large scale, like 300 million light year scale. The universe must be homogeneous and isotropic, right? So that is a cosmological principle. If you are at the center, that means isotropy is broken. If cosmological principle is broken, that means you cannot use the Friedman's equation. If Friedman equation cannot be used, modern cosmology cannot exist. You have to go back 100 years in the past, and you have to start from Einstein again. So that is a kind of, my understanding, a huge problem that we have. Let me go through this more here about the cosmological principle itself and what is the sort of philosophy behind it, okay? So let's examine the true meaning and the ideology behind the cosmological principle here. So the cosmological principle states that the universe on average looks the same from any point, right? That's sort of a reasonable sort of assumption here. It states also that the universe is approximately isotropic and homogeneous. Again, that is a cosmological principle. That is what the Friedman actually used in his assumption to simplify Einstein's equation into and convert into a Friedman equation, his own. So it states that the universe is approximately isotropic and homogeneous as viewed by an observer at rest. Now, here's the thing. It is motivated by the Copernican argument that the Earth is not in a central preferred position. And then what is the Copernican argument here? Copernican principle, what is it? In physical cosmology, the Copernican principle is an alternative name for the principle of relativity, stating that the humans are not privileged observers of the universe. It is a working assumption that arises from a modified cosmological extension of Copernicus's argument of a moving Earth, heliocentricity, right? I think Copernicus is not happy because that's not what he meant about this cosmological principle. People apply that argument into this principle. Now, in some sense, it is equivalent to the mediocrity principle. What does that mean? We are mediocre. We are not special. We are not God's special creation. We shouldn't be at the center. We shouldn't be at the privileged location. We shouldn't be at a special location because we are mediocre. Okay? And modern mathematical cosmology is based on the assumption that the cosmological principle is almost true on the largest scale. Here's a key point. The Copernican principle has never been proven, and in most general sense, it cannot be proven, but it's implicit in many modern theories of physics. Man, what is going on here? Isn't it interesting that the Big Bang cosmology is based on the assumption that it has never been proven and cannot be proven? What does this all mean? So Steve Hawking actually explains its bottom line very clearly. So I'm going to use his quote here, basically explains or summarizes what I already explained. Okay, so here's the quote. If you observe all other, so this is what Steve Hawking said in his book, A Brief History of Time. If you, and you can also, actually download whole thing in the internet if you want to read it, A Brief History of Time, okay? So if you observe all other galaxies to be moving away from us, we must be at the center of the universe. That's not what I said, that's what Steve Hawking said. We must be at the center of the universe, okay? There is, however, an alternative explanation. What is that? I also explained that, right? The universe might look the same in every direction as seen from any other galaxy. So that means if we use this balloon model and we put all our universe into this membrane of the balloon and balloon expands, then we can explain our observation where these redshifts, all these galaxies look to be moving away from us. It seems that these are really physically moving. If that's the truth, then we are at the center and universe has edges, but that contradicts the cosmological principle. So if the space itself expands, then basically you can explain the observation without requiring to put us at the center. Okay, so that is what this is saying here, that the universe might look the same in every direction as seen from any other galaxies. That is called, that is Friedman's second assumption. This is also a quote from his book. We have no scientific evidence for or against this assumption. Another thing, we are not able to make cosmological models without some admixture of ideology. We cannot construct a cosmological model without some admixture of ideology. Oh my goodness. What is going on here? Again, the Big Bang model is based on two theoretical foundations. One is general relativity. The other one is cosmological principle. General relativity is true. Cosmological, what is it? There is no scientific evidence for or against this assumption. Okay. However, we all believe it because that's how we have learned. And this quote from Carl Sagan, I guess you guys know Carl Sagan, the Dr. Sagan, he said this when he talked about the Earth. So you see this small dot, that is Earth seen from the spacecraft. I think there's a Voyager near Mars. This explains what the ideology means. The delusion that we have some privileged position in the universe are challenged by point of pale light. Our planet is a lonely speck in the great enveloping cosmic dark. That is a cosmological principle, which states that humans are not privileged observers of the universe. Now we easily understand Hubble's reaction on the observation that galaxies look moving away from us radially. It is from his paper here, his book. This hypothesis, it means we are at the center of the universe, okay? This hypothesis cannot be disproved. The unwelcome position of a favored location must be avoided at all costs. Such favored location is intolerable. To escape the horror of a unique position, right? So that's what he put in his book. And again, Hubble admitted himself later that the observed cosmic expansions could equally well be explained by the fact that we really are near the center of the universe. Finally, George Ellis is another high-profile geologist who has co-authored papers and books with Hawking in Scientific American magazine. He honestly admitted the role of philosophical assumptions. People need to be aware that there is a range of models that could explain the observations. For instance, I can construct you a spherically symmetrical universe with Earth at its center, and you cannot disprove it based on observation. You can only exclude it on philosophical grounds. Only exclude it on philosophical grounds. Okay. We are using philosophical criteria in choosing our model. A lot of cosmology tries to hide that. This is a quote, okay? So what do you think? There's clearly no issue with Einstein's theory of general relativity, but the cosmological principle may not be that certain. Therefore, we don't need to pivot our cosmology on the cosmological principle since it is not a proven scientific fact. And the current selection is what? The cosmological principle. It is just an assumption based on the mediocrity principle or naturalism or a philosophy claiming that we should not be a spatial being, all right? Then what if we put ourselves in the cosmological center of the universe? I'm not saying we are at the center, but we are near somewhere at the center, okay? Not random somewhere location, but maybe somewhere at the center, some important location. Because that's what exactly George Ellis said here. I can construct you a spherically symmetrical universe with Earth at its center. You cannot disprove it based on observations. That's what exact said. He's a cosmologist. He's a mathematician, very famous person. Okay, so this is not what I said. This is what George Ellis said. This is not what Steve Hawking said here. If we observe all other galaxies to be moving away from, then we must be at the center of the universe. Okay, so based on that, what if we are cosmologically at the center of the universe? Here, the cosmological center, again, means that we can be within billions of light years distance from the center of the universe. Please note that this is very, very different from and almost nothing to do with geocentrism or heliocentrism, nor flat Earth. Okay? These are nothing to do with those kind of things. Geocentrism is wrong, and flat Earth is flat wrong. Okay?